Good morning, everyone. How's everyone today? It's going to be a warm one here in Canada today. 18 Celsius, and we're, November, mid-November almost. Hope everyone is doing well. Today's stream is making a case for this thing. So actually, you guys are in for a treat because you guys aren't supposed to see this project for a little bit. Just moving OBS here. This is a project for another day, but I have to make the case for it. And the reason for that is because these switches, they are not held into the PCB. They are quick disconnect, so you can actually yank them out, and then you have the bare socket on here. So yeah, this is my attempt on making a macro pad that is hot swappable. So let me pull these out, and I'll show you a little bit of the features of this before we get going. These all come out like so. And there we go. So all of them are out. So now I can show you this up close. If you see here, there are two drill holes where there's a socket that comes through, and that socket is nearly flush with the PCB. See that? And then underneath here is a little RGB LED, which is controlled the same way as a NeoPixel. Now, the crazy thing is, there's only 4 connections here. That's it. So one will be positive, one will be ground, one will be the data pin for the NeoPixels, and then the other one will be an analog pin, which, if you can see here, there are resistances. See, R11, R8, 3, 9, 10, 2, 7, 6, 5, 4, 1. So they're all there. Those resistors will make so that when you hit one of these switches, it'll be a resistor divider, and it will send back an analog value to be read by the ADC of the Arduino. So this is a macro pad that you can use on any Arduino or any microcontroller with an ADC. So that means that, with only 4 pins, and really are the microcontroller pins, two microcontroller pins, one for the data for these LEDs and one for the analog value to know which button was pressed. So yeah, pretty cool. Good morning, Veroac. So yeah, all this, I believe I soldered all this by hand. It's been a little while since these have been sitting in the inbox. But yeah, pretty neat. Did I mark the mounting holes? I did not mark the mounting holes, so I don't actually know what the mounting hole spacing is. I don't know. Looks like you're... There we go. Enjoy editing. Congrats on getting the message out. So these must be M3 holes. So that's not a problem. But yeah, we're going to take the critical dimensions of this simply because I'm not sure how accurate the outside routing is in KiCad. So yeah, I'll make sure I get the right dimensions here and we'll get to it. So first and foremost, we've got a box. I don't know if it's square. I don't think it's square. I think it's rectangular. So go up over here. Good morning. Johnny B, I thought you were working. Sorry, I had to look across the room to my computer there to see who's typing. So this board is 90.5 in width. And it is 100.16. So that's right on the edge of PCBWay's $5 tier. Been trying to make the projects kind of small so that anybody can afford them. Okay, so we know there are M3 holes. But we'll just check the distance center to center. Mm, 84.43, 84.5. So that's from edge to edge. So 84.5, and then there are M3 holes. So if you add 3 millimeters to that, you get the center to center distance. And so 87.5 center to center. And then same thing over this way. It's 94.6. And then add 3 to that, so 97.6. Center to center this way. There we go. Nice. 81.5. Did I mess that up? That's a 7. So 8.4. I'm getting 8.4 1/4 now. Getting 8.4 now. No, there's 84.4. Oh, -3. Damn, you're right. So 81.5. And this one here would be 91.6. Thank you for that. Okay, now I believe these pips on the switch, I believe they are exactly centered. So if we measure center to center distance, we should be able to get the distance between the two. I don't know if I'll be able to pick up the actual hole diameter, but we can look it up in the data sheet. It looks like 4 mils. 4 millimeter hole diameter. And so if we go center to center this way, they should be symmetrical. So 24.3. So we got 24.3 minus 2, and that'll be 22.3. So let's see here. 22.3. So this is the only thing I don't like about KiCad is that electronics are ruled in like 0.1, sort of 0.1, is it inch? Yeah, 0.1 inch spacing. But I wish you can get just a standard, you know, if you could switch to a mechanical layer and just have an exact ruling, you know, without the 0.1 spacing. And then if I go this way, 4 mils, 24.3 again. So this is actually symmetrical. Okay. So that's 22.3. Okay. Now the other issue is that I need to locate these somewhere on the board, and I could measure out from the edge to there and out from the edge to there, let's say. So let's try that. But then if we have any induced error when we multiply on the side this way and this way, yeah, that'll be a problem. Hey, Doug. No, I had to work yesterday, so started a new job, and so he needed me in yesterday, and I gladly obliged. So it's 24/7. The 24.8 from there, and then from this side, $12.8, so plus 2. $14.8. Okay, let's try that. The other thing is I want to make a nice stand to stick this up, like kind of like this, and also we need a hole in the back for the wires to come through. So, all right, I think we're ready to go over to CAD. Let's see if I can remember to switch my screen. There we go. Welcome to Fusion 360, as always. So I kind of sort of cheated, and I've actually designed this before, but it didn't fit. So I felt like, so this is what I designed here. God, I never remember the controls when I come back into Fusion. Shift, no. 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 Control, no. Oh, there we go. Middle mouse click. So this is the design, but yeah, it didn't quite fit. So I'm going to start from scratch with a brand new one. So new component, standard V2.1. There we go. So let's get started. So I think this time I'm going to design the actual board in CAD, and then I'll try to build a case around it. So let's start with the board. So the board is a 100.16 by 90.5 square. So let me make a new component, call it PCB, and there we go. And we'll start this component, making a sketch, this plane, and then we make a rectangle, 100.16. Oops, that's 90.5. 90.5 by 100.16. Okay, so that's that. Oh, I didn't get the mounting hole spacing. Well, we'll do the mounting holes after. All right, now we know we need a hole sized 4 millimeter, like so, and this needs to be constrained. Well, we need a how do you get the, oh yeah, middle, there we go. This to the edge here, and that has to be constrained. How do you set the dimension? Huh? No. Don't remember how do you make it. That's how I figure everything out. How's everyone today, by the way? Oh. Just create the length you wanted in the first place. That makes sense. Okay, line here to here. Or, well. Wait, do I have the center to center? I do have the center to center length. Okay, that's good. Then that's ideal. That's what I wanted. 24.8. That seems wrong, but that's okay. Long day yesterday. At work, I'm guessing. 14.8. Okay, and then this. Coincident to this. And this coincident to this. There we go. I can take this, turn it into a construction line. Now that, no matter what we do to this side, this will move, which is good. Sorry about the coffee drinking noises for those of you that don't like humans making noise. 22.3 over. All right, so now I need to turn this into a pattern. There is a way to make a rectangular pattern. Rectangular pattern. All right, so the object, this, we need to go the other way. And it is minus 22.3. And there are 4 of them. Oh no, it only makes the... So I have to multiply it a couple times. Because it only makes the 22.3 is this one, I think. So 22.3 times 4. 89.2. Let's try that. 15-hour workday. Okay, that didn't work. Why? Why do you forsake me? Oh, 4. Still. This doesn't make any sense. .3. That should be the distance between here. No, it can't be the distance between here and here. So it must be, oh, it's times 3. Oh my God. Sorry, my brain is mush right now. 0.3 times 3, 66.9. Let's try that. Minus 66.9. That looks correct, except this hole looks really close to the edge. What have I done? 24.8 from the top. 14.8 from the edge. Maybe I did my 14.8 improperly. Let's see. Screen plus cam. Good morning, Franco. Scroll down in a little box and switch. Little box. Oh. Why do they do that? Give me a bigger box. For one direction. Give me a bigger box. Not this way, the other way. What am I? Oh, you guys can't see what I'm doing. Oh, there we go. What am I switching? One direction, quantity 4. So something's wrong here. I got one of my dimensions wrong. If I check this from the edge, 12.66 there, 12.66 there. So 12.6 plus 2 is 14. Okay, is my width actually 90? Yeah, 90.5. What is going on? This looks completely wrong. Oh, switch to spacing. 22.3. Okay. So, this is good. That's fine. I don't know what suppression means. Everything is good, except this doesn't line up. So you know how I said if I get one error, everything gets weird? So this is the problem. What does this mean? Distance from what? Oh, okay, the other direction. Okay, that's okay. So, okay, here's the issue. I'm going to try to do this on camera. So from here to here, 12.8. From here to here, 12.8. These holes are 4mm holes, ish. And so it's 12.8 plus, no, I did it from the center. 12.8 plus 2, which is half of the hole, to give me 14.8. And so if I grab this dimension here is 14.8. And so that's fine from here to here. But over here, that is like, let's say 10. Yeah, this is 5, 10, 14. This is like not even 10 mil. So I'm not sure what is going on. Okay, let's see. You know what is the, yeah, 22.3 in between. It must be the 22.3. It can't be. You have a new channel, Johnny? What's your channel about? Oh, that's my mistake. It's 16. 16.68 in between these two plus 2, that's 18.68. So the spacing is 18.7, not 22.3. Don't know where I got that from. 18.7. Okay. 18.7. That looks a lot more legit. All right, I'm gonna check the vertical spacing again. Have to roll between my PC and that's 16.5. Pretty consistently. 16.5. 16.5. I'll just make sure this isn't 16.5 over here. No, 16.8. It's not exactly square. That's okay. 16.5 plus 2, that's 18.5. And then minus 18.5. And quantity 4. That looks a lot better. Okay, the Johnny B channel, post my Twitch live streams there, Sniper Elite Gaming. Nice. How you liking Sniper Elite? Okay, so there, that makes a lot more sense. Don't know where I got my erroneous numbers from, but I guess that's okay. Okay, so that's done. Now, does my board really have a large bottom end like that? No, it doesn't. Something is wrong at the bottom too. So the bottom of 12.6 from the hole. Oh, maybe I'll just check my vertical. It's 22.8. 22.9. So from the top, I have 22.8. That's okay. So this is okay. So, and my spacing this way is 18.5. That's good. Why is this not lining up? Let's measure. What's the center to center distance again? 18.5. That's good. What if we measure here to here? 19.8. It's not what I'm getting here. That should be 12. So maybe my board vertical wasn't properly measured. 100. 100.15. That's what I have. Okay. 2.9 plus 2, 4. 12 should be 14 on the bottom. Maybe I have one row that's not right. 16.6. 6.6. What's the distance between these guys again? Oh, you know what I forgot to do? It's 2 circles. It's not plus 2. It's plus 4. That's my mistake. Okay. spacing. Yeah, you can post a link. Post the link to your Twitch and your YouTube in here, Johnny, so that people can go take a look. All right, 4 by 4. No, it has to be 18. No, it is. Oh my God. It's a 4mm hole. I have to add 4. So 16.43 should actually become 20 point something. 20. 16.5. It's 20.5. Negative 20.5. I think I got it now. And then vertically was so I'll go 20.6 and then 20.5. That makes a lot more sense. That is now accurate. So between here and here, we should have close to makes no difference 14.8. We're off by, so 13.9. We're off by a millimeter. 0.6, 12.7, 7, 7. Should have adjusted these. It's 14, so I'm off by 0.7 on 3 stretches. So divided by 3, 0.23. Can I redo that pattern? Seven. Rectangular pattern. So 20.4 and 4, and then 20, what, 0.7. There we go, 0.9. Let's see if we can split the difference. 16.5, 20.5. Negative though, negative and negative. And that should be pretty close. 13.1. Did I just do the same frickin' thing? My God. Now you can see how come this takes me so much time. 20.7, we're gonna add 3, so 20.9 that way, and 20.5. Yeah, okay, so I'll show you why I don't use the PCB itself. It might be my misunderstanding of KiCad, but it is a bit complicated. Okay, so now what is going on here? Okay, give me a second. 4, 4. Oh, I took too much. 20.7. I should go 20.6. I need to go down, not up. And then 20.5 still. Negative. I wish I could measure now, but let's see. 3, 4, that's 5, 10. I think this is closer. Okay. 14, that's 14.7. Most importantly, distance between these two is 20.6. If I measure these, I get 20.5. 20.6, 20.7, depends on where. Get it, 20.5. Very difficult. Okay, so I will show you. This is the KiCad project here. I can even go back to just the screen. So this is the project. So the issue is, it's like very difficult to get your reticule in the middle here. But let's see here. If I use the measurement tool, okay, there, I'm in the middle, here and here. So that's 20.3 actually. So maybe the issue is that my holes are not exactly 4 millimeters. That's very possible. How big is the edge? So my edge cuts here. So you see I can't get the cursor directly on it. I'll keep skipping around. That's the difficulty. And then if you change the grid will never, I don't think the grid will ever align. See, that's like still not grid. See how, like, where is this line cut? Is it cut on this side of this line or on this side of this line? So I can't use the edge to deal with any of that. It's very hard to align to the very center of something. It's not, you know, it's probably just me and the way my brain works. But like, yeah, I can't get it right in the middle. So that's my issue. I think this one is easier because they're footprints. No, but even so, it doesn't let me. 0.1, nope. So if anyone knows how to get the exact centers, well, if I take off snapping, okay, let me see. Preferences. Let's see. Let's see if I can remove snapping. Preferences. Mouse. Okay. Scroll gestures, no. Yeah, you know, I really love KiCad. I think it's super capable. I know it's me that the issue is here, because this software pack is like way more powerful than I could ever need. But it's learning where these things go. Let's see. Preferences, PCB new magnetic points. Let's see. It's called magnetic points. Oh, snap to grid. Always. So if I remove snapping, oh here, when grid shown. So maybe I can just hide the grid like this, but it still won't snap to the center of my footprint. You see what I'm dealing with? Well, take this thing, this guy here. It's clearly. Oh, look, I have a reticule for the center, but I can't snap to it. Measure. Okay, now I can snap to that. Okay, so in the measure thing, I can snap to it. It snaps 20.320 and 20.320. It's actually identical, so maybe my holes are a bit oblong. Okay, but now can I go? But see, I can't snap to my edge cuts. I can do rotation 180 degrees. And then like 14.456 to the inside of that line and 14.560 to the outside of that line, but I don't really know where it's cut. So I can also do like zoom in big time like this. I can measure inside to inside. Rotation, gotta go exactly 90 degrees. Whoops, 0 degrees. That would be 89.9, but that's not the width of my board. My board is 90.5. So there's the 90. I don't know if my board is, no, it looks like it was just milled out. It was not V-scored. Just looking straight down the edge there, and it's pretty parallel. Oh, I could do corner. Well, if I can do the corner to the corner, it gives me 90, and my actual board is 90.5. So half a mil of wiggle room, maybe? Okay, let me just deal with this grid, and then I'll do everything after. So center to center, it's 20.320. Center to center is 20.320. So it's actually a symmetrical grid. So let's go erase this, and then rectangular pattern 4, 4, 20.320. That's negatory. Do you see my struggles here, why I'm an iterative maker and not a one-shot kind of guy? So there we go. So you would suggest V-scoring, but didn't you just say V-scoring is not precise? Okay, and so it gives me like there. Okay, so now if I just grab like one of these randos and go out to here, uh, 90 degrees. It's like somewhere here. Okay. So between 24.5 and 24.65. Okay, pick a hole, reference from the holes. Yeah, the problem is, so I'm building a case though, right? So I guess I'll make the case edges not super precise then. Don't have much of a choice then. So I guess I should get this hole's location by this hole and then just go hole to hole. All right, well, it's a thing. Okay, so now what do we do when we measure? 14.8, it's actually much closer. Much, much closer. Okay, so let's put M3 hole. it's 3, I think it's 3.2 actually. 3.2, like so. And let's just align it with this hole. Yeah, the actual important part is actually the key switch spacing, which you'll see very shortly why. So these key switches are actually supported by the case and not by the PCB. All right, so we got here and we got here. So now we can use, see, this is what I do like about KiCad though, is the XY stats right on it. So I can actually, it says, you know, on X it's negative 10.160. So negative 10.160, and then on the Y, it is negative 20.320. You're an engineer. Yeah, the approximate. Okay, so 10 minus 10.160. By the way, if anyone's watching this stream and you have a better way of doing these things, I'm I'm all for it. So I need a vertical line. No, what am I doing? So this needs to be 20.320. 20.320 in length, very specifically. And then this to this needs to be 10.160. Okay, and then this dot this dot needs to be fixed to this dot. Your support is all I need, Franco. I'll make it through this. If eventually. Okay. Now grab here to here. That's 81.280. This 81.280, and that is there. Can make a hole. Oops. .2, like so. And then this one here, between there and there, that is 91.440. What a pain in the butt. And gotta make sure that's exactly 90 degrees. Okay, and then this 3.2. Same deal. And then another one at 81.28. stuck at 0. Construction line 3.2. Okay, done. At least close enough to done. These are critical dimensions, so they should be okay. And then the board, I guess, yeah, we just leave a loose tolerance around it. So there's the PCB. And PCB thickness is measured to be, should be 1.6, yeah, 1.65. Okay, 1.65. Finish sketch, grab this, extrude it up, 1.65. There's our PCB in all of its glory. Okay, good. Need another new component. I'm just going to activate this component. New component, and now we want case top. Thanks for being here, Johnny. Enjoy your lunch. Okay. Hopefully all this is equal and it all works out. Now we need to make another sketch for the top. So we're actually going to make it on top of this. Now here's the deal. We need to make it to Cherry MX standards. So Cherry MX switch dimensions. There we go. Mounting. Okay. This must be inches. Yeah, inches. In brackets, millimeters. There's no millimeters in brackets. Okay. Okay, this is a cutout for like a CNC. So 14 by 14 is what you need. And the installed height is 5 millimeters. Right? Does that make sense? Hold on a sec. Open image, new tab. Okay, so it says that the outer dimension here is 15 mils, 15.6, but actually that lip sits on top of the case. I just need the actual mounting. Without mounting pins, with mounting pins. That's the keycap. I need to know this opening size here because it sits right into there. Man, this is a pain. I had it, I think I'm pretty sure it's 40 by 40 when I had looked it up last time. Let's see. See if I can measure. Here and here. 14 by 14, whoops. And then 5 mil installed height, pretty sure. So how big is this? 1.5 mil, and then the height, 5 mil. Okay. All right, so we have our new sketch. We're going to edit, and then we need to give me my sketch. Oh, I'm in the sketch. Okay. Okay, need 14 by 14 squares. 14 by 14. Like so. And then we just need to multiply this. Rectangular pattern, spacing 4 by 4, 20 point, what was it again? Dang it. 20.320. It is and it isn't complicated. It's a lot to learn, but I really wish that I can just make, you know, like regular CAD models, oops, in KiCad. It would be just so much easier. Okay, so there we go. That's what we need. Okay, and then we want to make a rectangle around here a little bit bigger. And basically our PCB is going to sit inside of this. Okay, so yeah, we want to make this a little bit bigger. I kind of want to center it in between these two. How to make this like centered? So that's the center of what? So if I take these two, put a line in between them, that will be the center point of this. So if I take that down like that, this is centered. Yeah, like something like Tinkercad is easier, but the thing is it doesn't integrate well with this. You still need to transfer dimensions over, which is the part, like I wish, because so the thing is electronics are on a like 0.1 inch grid, so 2.54 millimeter grid. That's really hard to translate that into, like, I wish I could take KiCad, turn the grid into 1 millimeter grid, move my components, my like mechanical things around, like make a switch grid or whatever, and then still have the 0.1 inch grid for things like, you know, for things like parts, Like put parts side by side. And I mean, there's probably a way to do it. I just don't know how to do it. Okay, so you can make a center rectangle now. Here, center rectangle. And my board is roughly 100.16 by 90.5. So 100 point, no, 90 point, I'll add, I'll do 91 point, 91.5, I'll add 1 mil for clearance. 91.5 by 101.16. Oh no, what am I doing? It's not centered. It can't be centered. It simply cannot, because of the fact that my board is not centered. Oh, what a bother. Okay. Oh my God. Okay, so if I want 91.5 91.5 divided by 2, 45.75. I take this and do a 45.75. This way. Turn that into a construction line. So now I know where the corner can be. This is actually quite annoying. Okay, what's my scale here? Here to here. Here to... Okay, so 1 mil is like here, right? So half a mil is here. So I'll start it up there. Oh no, I want a rectangle. I don't know, there. That should be close enough. And then, so I want 101.16 by 91.5. Okay, that is the dimensions of my board in this case. And now I need to make a wall for the case. And so I'm going to go expand this, offset, negative 2 mils. Okay, there we go. I'm going to take these corners, I'm going to taper them because they look ugly. Fillet. 1.5 millimeter fillet should do. Like so. That's good. And now I need some strengthening ribs. which I can put anywhere inside here. And that should be good. All right, what kind of strengthening ribs do I want to do? Thinking. Oh, I also need to make these holes strong. Well, it's not that I have patience, it's just that I love the fact that I can do this. I keep expecting myself to get better and better with time. That's not really happening, but I hope so, right? One day I get really good at this. It just is what it is. You kind of have to, I mean, it works parts of my brain, which I'm really glad get to work. So it's, you know, it's a thing. Okay, so I also, I have to think kind of like upside down and backwards too. Do I care about stuff shining through? You know what? No, I'll probably be okay. I'm trying to think here. Let me finish this sketch, and I'll iterate on this. Okay. So if you think about it, if my PCB is planar here, right? So we need to grab these little edges too. Okay. And I want to stretch this out. And I believe it's 5 millimeters up that I said. So let's put 5 millimeters up. Oh, made a mistake. Let's try that again. So I want this whole thing, plus this, plus this. Everything to come up, even these. The only thing that'll like not be on the surface is the holes where the switches go through. Okay. 5 millimeters up. There we go. I'm going to change the color of my PCB as well so that we can see it. Appearance. Appearance. Wood. Glass, liquid, metal, mirror, miscellaneous, air. Oh, we'll make it a carbon fiber board. Okay, and then pop it onto there. There we go. So my PCB is carbon fiber. Good. All right, back to here. Case top. What have I done? PCB, yeah? What did I extrude? What have I done? Oh my god, I'm an idiot. I'm just gonna delete this. Okay. Let's try this again. So, this, this, this. All these, plus the space in between here. That needs to all come up, and you're going to be 5 millimeters tall. There we go. Okay, so there's my top case, and if I turn on the, if I go over here So there's my top case. I can hide the sketch with the PCB underneath. Okay, good. Now I'll go back to here and I will turn on the sketch and we'll look at the bottom. Okay, so now I need to take this up, extrude. We'll give it a couple mils, let's say like 2. Oops, -2, I guess. Don't even know where the dialog box is. Oh, there it is, -2. Okay, turn off the sketch. So now we've got a place for, get rid of this body. There we go. So we got a place for the PCB to sit in. We need to drill the holes. We'll get the sketch back. Okay, this, and this. So we've got 5 mils. We'll just we'll drill in 4 mils. Extrude 4. So we drilled the hole. Now I got to make the hole smaller, or else the screws don't stick to the hole. Three, 4, and we're going to make them. Oops, 0.5. 0.5 is too big. 0.25. There we go. So you see, like this part I can do quite easily. That's not the part that's the problem. Oh wait, no, my switches have to clip into something. Right? Hang on. I need a lip. Okay. Yeah, I think I need a lip, right? Because they have to clip. So, how do I do this? If I have to select all these things, it's going to take me forever. Whatever. Do it this way. Nope. Grab all these faces. So if you folks watch my YouTube videos and you see that I've made a case for one of my projects, this is how long it takes. Okay, so like so, I'm going to press pull them. I'm going to go -1. Is that too much? No, I think that's fine. -1. Done. Take that sketch back up. I need to grab all of these. No, I need the bodies there. Yeah, okay, this whole thing. Yeah, that's good. And then extrude. And I don't remember if it was 1 or it was 1.5 in my other sketch. 0.5, cut, but join. Whoops, it's on the wrong side. Okay. Plane offset. 3.5 millimeters. Thank you. I appreciate you saying that because this is, as you can see, a shit ton of work. It should be completely flush. Okay. With the sketch. Okay, so what I did there is I took the holes I made them bigger, and now the switch will clip into this ledge here. So if you look at the cherry switch, see how it has a clip here, this part here? See how that has to go like this? And so you need something, you need to clip onto there. And so, yeah, right here. And so that's what this is here, this lip. That's the 14 by 14. I'm getting nervous though, so let me double check. Screen plus camera. Okay, so let's zero it out. Right below the clip here. So 13.93, so 14 by 14 should fit in there. Good, so give some clearance for the rest. All right. I think that should be that. I don't know if the front has to be much more fancy than that. The board will sit right in there. It has some play around it. Here's the question. It's 9:30. This might take like, I don't know, half an hour, 45 minutes to print. Would you guys be interested in seeing a finished product like this thing? Should I start printing it now so you guys can see it done? If you want that, I will start printing it right away, and we'll see if we have to iterate. Yeah, that's exactly what it is, Franco. Let's go back to just the screen. You know what? Screw it. I will print it anyways. I'll just hide this so you guys can't see my stuff on my computer. Save as mesh. STL, yep. And then to STL save. Let me just open Cura and I'll bring you guys back. I do have a 3D printer that a company has sent me a while ago, and I was really disappointed with it, but I think I figured out how to make it work. And so we're going to try doing it on that, simply because it's the only printer I have right now that is actually clean. There's nothing on it. Okay, bring you back to the screen. Wait, gonna hide you for a second. Back on the screen. Okay, so drag that in. So there it is in Cura, ready to go. Going to place that downwards like that. Gotta change these settings. Skirt. I don't know if there's enough filament in it, but that's okay because, you know, I'll figure it out after. And I want it, extra fast. Skirt. Let's keep changes. And I want it to be skirt. We'll do 2 lines on the skirt And I want no supports. Come on, load time. 1 hour, 34 minutes. That'll bring us to 10:30, bring us to 11. I think I'm gonna do it. All right, so. See if I can make it a little bit faster even. Line thickness, count top, bottom. I just need 2 top layers. Let's go. Probably save me a couple minutes, yeah. All right. Eject. All right, you can't see me, but I will talk you through it. I'm going over the mess of stuff, plugging the USB drive into the printer, hitting print, confirm, and it's heating up now. So hopefully it takes a little bit less time than the estimated cura time, and then I'll get to show you the printed product. All right, so that's done. Back to this. Now we've done the top part, we need to do the bottom part. So the bottom part, I'd like to sit it on a desk, and I also like to make it so it's not, doesn't take up a lot of space, a lot of printing. Hopefully the 3D printer will print it properly. It's an experimental printer, so, you know. PCB, yep. Let's get that component, and we'll do new component, and we'll go bottom 1. Okay. Wait, that's not what happened. What did I delete? It's very specific. You have to be, like, you have to know exactly what you're doing. By the way, can you hear the how loud the fan is on that thing? Okay, so bottom 1, want to create sketch. But first we want to show that body. We want to show that body. There we go. Okay, so we want this as part of our sketch. Whoops. Yeah, well, trust me, it's incredibly loud. So we want all this as part of our sketch. How do you offset? No. Let me do it. I want to be on this line. Oh my god, this is frustrating. Oh wait, I need to turn on the sketch. Right? Let me do it. God damn it. Oh my god. It's like doing something. I wish I had a second webcam over there, but it's like really far. At some point I'll have a better streaming setup for you folks. Until then, you'll have to deal with mediocrity.
Why is that there? I want to make... I want to sketch here. Okay, maybe I'll... I want to be exactly on this line. Keep zooming in until I see frickin' electrons. Okay, I have an idea. I won't do a sketch. I'll just take this, and I'll grab this, and this, and all these. So, bottom of my board, plus this. Whatever. Oh no, I'm still in the sketch. Finish sketch, go away. Okay, I'm gonna grab this. I'm gonna pull it up. Extrude, I don't know, like 5 mils. There we go. So I don't have a sketch, but I made a body. It's good. Let's erase this sketch and this sketch. And then I can grab all this. What do I want here again? Let's get rid of our PCB. Oh no, this is perfect. No, this is what we want. Yes. Erase this. Erase this. Okay. All we have is this. Another sketch that's showing for some reason. Delete this sketch. Okay. So there we go. So we've got, finally. So for the back of our, yeah, so we want to bring in the mounting holes. That's what we want. And then I need to make legs that this will hold up on. Okay. So, I do want this plane, though. What side is top? Yeah. Okay. So I want this. I want to create a sketch. And then I just want to finish this sketch. I just want to grab this. And I want to bring it up like 3 mils. No, I want it the other way. This, bring it -3. There we go. Okay. Now we're cooking. Got this. All right, now you want to this side there. Create a sketch. And now we want to bring back the mounting holes. Oops. Nope, not that one. My PCB, I guess. Yeah. So we'll bring back these mounting holes. Let me, rage. Sketches, get rid of the body. Why won't you let me Just show me your freaking sketch. Wow, this is like infuriating. For whatever reason, it's not working. I just want to grab the mounting hole locations. Please, 3D printer. Oh, the 3D printer might run out of filament too. Let me make sure I have some filament set up for it. What do you guys think? Pink, purple or pink? Those are the two options. There's either, here, let me bring you on. Webcam. Pink? Okay, I think this is pink. Nope, that's purple. So this one's purple, like that. You guys can't really see. And... oh. Well, something just fell. This is pink, so this one will do. So this one will be the one we're going to use when the 3D printer runs out of filament. This was incredibly cheap filament, so it was on sale. It was a 2-pack, and I believe the 2-pack was priced as if it was a 1-pack. So I bought two 2-packs. So yeah, this one here is what we're going to use. Purple for production run, pink is for prototype. Well, we are prototyping, so it's perfectly fine. God, it's just making everything fall. I'm gonna walk you through what I'm doing here. Just gonna check the printer. This print might fail. It's not sticking very well. We're gonna let it go and see what happens on layer 2. Oh boy, it's not looking good. It's like stringing around like crazy. Well, I'll let it be, and hopefully it doesn't end up a blobbed mess, and if it does, well, then it does. The filament that I'm printing with right now is what came with the printer. It is what it is. Okay, back to the screen. Okay, let me pick up, why don't you let me pick up the holes? Okay, you know what? I'm gonna just delete this sketch. I'm gonna pick up the body, right? Yeah, there. Gonna hide this body. Gonna see if I can just grab these holes. Oh boy. These holes like that, and what if I extrude? My God, why don't you let me do it? No, no. This is like the most frustrating time I've had with the Fusion. Okay, put my body back here. Take my PCB. Okay. Extrude. Okay. What if I activate my PCB? And then extrude. No. Why can't you just fill in the keyholes? I'm not quite sure what that means. Okay, let's... No more bodies. All the bodies go away. Okay, we're just going to find our original sketch. This one. We need this one. I'm going to grab these mounting holes. Like so. These are the important dimensions. Then we're going to activate our bottom. Right. PCB sketch is still there. Oh. Is it because the sketch is buried in the body? No, it's right here. Aha! I grabbed them. We're good. Hey, Bigsy. Everything is going frustrating, but I think we just solved it. Because of the incredible team of chatters. Okay, we did it. I cut the holes. Jeez, that was like much more complicated than it ever needed to be. Okay, so the bottom of the PCB has a lot of stuff. So I can't have this whole thing be solid. So yeah, it has, wow, it has a lot of stuff. I can't have anything in there. So what I'll do is I'll make it just go around and support the edges. Yeah, progress is being made. Actually, I'm printing a part by overwhelmingly popular demand. So the top of the case, this one here. So this part right now is being printed as we speak. The printer might fail. I'm looking at it. It's not making any blobs. Ugh. It's not sticking very well. But we'll see. And also when the filament runs out, we're going to switch to pink filament. Oops, I should have left it open. I'm going to be switching to this stuff. Pinky filament. All right. And then we're going to hide this component again and start working on this guy again. Activate this guy. All right, so yeah, I have tons, there's components everywhere in here, so I can't just have stuff hanging around. Also, I need to check the PCB. Okay, so this side is actually the top. I have to make sure there's a cutout here for my here, I'll work with the top being on top. There we go. Oops, back to the screen. Favorite thing I printed? Have you seen my RC Snowspeeder? That would probably be my favorite thing because it's a finished product, which is nice. All right, so now we can create a sketch on this. Yeah, I realized a little bit too late. I'm not exactly a pro streamer. If you want some pro streaming, you can check out twitch.tv/Veroac. She is the pro. All right, so I'm going to take this and I'm going to offset this way. How much space do I actually have until I run into components? Let's see, I'm going to switch over here.
it's not like I built a macro pad for or anything that I could be streaming on. So there's a component here, and that's the closest to the edge. So really, I only have about 2.8 mils before I hit the edge there. That was dumb of me. I really should have shoved this over if I was thinking more about the production aspects. So 2.7 mils worth of edge. Should be enough to support it. So 2.7 on top. Look, I have not much room here. So, yeah. So 2.7. Bottom, I have a lot of space. I'll go about 5 mil on the bottom. So 2.7 on the sides, and then on the top I'll have to have very little support. Screen. All right, so minus 2.7. Oops, minus 2.7. Like so. So I know that's my safe edge. And then on the bottom, I can go even more. So top is on top, so on the bottom I can take this guy and offset that one. Oh yeah, it doesn't want me to offset an already offset plane. Whoops. Offset. So I'm going to go like -5. Was it 5 mil? I don't remember. It's not like I just had it in my hands like a minute ago. Yeah, 5 mils. Okay, so that's there. And then obviously I want a little bit of space around my circles. So I can take this and I'll offset these guys. Come on. Let's see. Probably can go about 3 mils. This offset 3. This guy offset 3. This guy offset 3. There we go. And then you can just go in and snip whatever isn't needed, or if you know that this is good, that's the first offset. Oh, and on the top I have to deal with, I have to go a little bit narrower too. Probably on the top what I'll do, yeah, there won't be much support on the top, sadly, because I need space for, there's a component in the way, which is sucky. Okay, I'm actually going to make a rectangle, maybe here. Here to here, grab this and fillet it like so. I'm going to make a similar rectangle here. This one can't be as big. Like this. Grab this guy, fillet it. Oh, no, oh, it's not what I wanted. It's a fillet.
3.5, like so. There we go. Yeah, I could, but that would mean having to quite accurately measure out. And I'm just not great at measuring like that. Oh, I just found a problem too with the part we're printing. Oh well. There's not going to be enough space for my soldered on connections. But if I solder them flush, it should be okay. And plus, there's always room for a V2. So anyways, take this, and then I can just chop. Oh, finish the sketch. I could take that and just chop it out of this. Whoop. Damn it. Just had it. Like this, and then extrude, chop it out. There we go. So there's the support frame. And then all I have to do now is make some legs, and it should be good. So how much angle do I want this to sit at? That's a good question. So on my desk, I want it. Let's do it at a 45. If we do a 45-degree angle, I think we'll be in good shape. So I'll make a sketch on this side here, like this. And we want to start from like there. How many millimeters up is that? Take a line, go from here. Here to here, 1.5. Just make sure it's going out in the right direction. It is. Okay, 1.5. Go to the other end. So far the 3D print is sticking down, which is good. Okay, take a line halfway down, there, out 1.5. There we go. Turn that into a construction line. All right, now from here to here, I'm actually going to make my other construction line here. This. 1.5. Okay, so now I want a 45-degree angle from here up. Grab this and make sure it's 45. And then like, it's gonna be huge. Like so. Then I grab a line from here. And this gotta be 90. It might. It might. Let's try both. We can easily make both. This and then 30. And then we go all the way up like this. So there's a, so basically, there's a 45 and there's a 30. If 90 is flat, yeah, I think. So Chad is saying roughly 30, if I'm reading that correctly. And then we can actually take a line from here to here. There we go. So this should be Oh, and we need a line from here to here. So there we go. So 30 degrees. I mean, hey, we'll try it. It won't print with, it won't require a lot of material to print because it's going to be trimmed anyways. Okay, so what I will do, okay, finish sketch. So I'll grab this, and extrude it up to the top of the 30-degree plane or so. And then what we're going to do is we're going to grab I want to take okay, I think we need to modify this sketch and then make a box. Like that, and then finish sketch, grab this and this, then we extrude. We can just chop that off like that. So there's the 30-degree case. And now we can even like chop off sections of this to make it use even less filament. Can definitely do that. Yeah. So let's chop off a little bit. So let's grab, let's say, make a sketch here. So let's make a rectangle. This plane here. Where's the other sketch? Make a rectangle here. Here even. Can do something like let's say like this. Then we'll take this and fillet it down, sort of like that. Cut out an SE logo. It becomes hard to print then. Something like that. I will grab this and I want to keep that little nub in there. Maybe I actually want to back this up a little bit. Gonna make another rectangle here. Welcome back. Finish sketch. So we'll take this section. Actually, I'll even, can I make this? No, I can't. That's okay. I'll fillet it after. So we take this, extrude, then like take the little arrow and smashing it through there. And then just to make this hook look a little nicer, you can grab this and this, then add a fillet, There we go, 2.5 mils. Erase our sketches. There's our 30-degree stand. And then if we add it to the top piece of the case and the PCB, oh, where's the PCB? PCB, body is there. Body is there. I don't know where the PCB is. It's hiding. I see it's clearly there. Oh, you know what happened? When we cut over here, we cut out our PCB by accident. Whoopsies. Where was that? How do I restore extrude from the case top? Extrude from the bottom. Oh, the 3D printer's making weird noises. Extrude 2. That was good. Cut the holes, that's fine. This one, okay. Hide this. Enter. We go back here. There we go. Now we got our PCB back. Okay, so here is our finished PCB. Now I can model the switches, but I don't think that's useful. Oh yeah, I need to chop one more hole here in order to let the wires through. So that actually becomes a little bit difficult unless we make a triangular hole. And I think that's what we're gonna do. Triangles for the win. All right, so we can erase, get rid of all this stuff, work on the bottom again, get rid of these bodies so we don't accidentally chop them. And then what's the distance here? 3 mils. Okay, so create a sketch here. Oh no. I mean, you can drill after you printed it. That is for sure something you can do. But the thing is, I like when people don't have to do extra work. Some people aren't handy, you know, they have 3D printer, they don't have a drill, stuff like that. Okay, and now how wide do we want this? We can go pretty wide. Can you create a triangle? I don't think they like triangles. Make a 3-point rectangle though. So let's say I don't need all that. Like let's say here. Then, oh, 69, I like that. 69 in length, but I want it in line with this. Oh, that's not what I wanted at all. Okay, try this again. Oh, maybe I'll just make a center rectangle. Center rectangle. Oh, but I want it rotated. Okay, all right. Let's do 45 and 60. Like so. Then I can take this and rotate it. Can I not? Move? Rotate. Yeah, there we go. All right. How do you rotate this? Let me rotate it around the center axis. No, the middle. Around the like the Z axis. God damn it. Okay, it's not working. It's not working. Nothing's working. All right, let's try this again. I'll go down, let's say 50 mils. And then we want a 45-degree angle, because printers can print 45s. No, that's too big. 40 mil. .45-degree angle. I want it in line with this. Ah, you bastard. I'm gonna do every little detail by myself then. Here, here, turn that there. There we go. Every little detail I'll do then. What's 90 plus 45? 135. And then here, and then what the hell is that? 90? Oh, it's grabbing from the other one. Yeah, 90. There. And then I can make a line from here to here. Actually, I think it would be cool if I made other triangles here. But I think that would be ultimately a lot of work. Yeah, I'll stick with this. Sketch, grab this guy. And extrude. That looks a little floppity. Not sure if I like that. Maybe I'll just make a much smaller triangle. Let's see. You can make a rectangle hole. Maybe I'll just make a rectangle hole. I give up. Oh, not create sketch. That's not what I want to do. Sketch. Oh, nope. Center point. Rectangle. No, it doesn't need to be that big. Not at all. Extrude. Bing. Done. There we go. Most 3D printers can close this gap. So I'll just leave it at that. That should be good. The back will be mostly closed. There we go. Second part's done. Let me just check on the 3D printer. Again, you won't be able to see me, but I will talk out what I'm doing. Yeah, she's printing 27%. Says it's been going for 44 minutes. I mean, it's doing the rapid parts now. It's the parts where it's just going a little nuts. I feel like I fixed this damn printer. The people who sent it to me were no good at customer support. So I'm pretty glad that I didn't like recommend it. Well, how could I? It wasn't even printing right. Okay, I'm back. All right, so hopefully this is enough support. And now our full thing looks something like this. If we go here like that, body and body. Let's see if I can. No, I'll rotate it just a little bit. Let me turn it. Whatever. Give up. So yeah, it's gonna sit on the desk a little bit like that. And then, yeah, you'd be able to mash buttons. I could put some text here, but I don't really want to. I'm not very vain. I don't have much vanity, so I don't really need to do that. So that's done. So now that this is done, that's another PCB project. What do we do now? Can put the switches back in. In case those of you joining a little bit later, this is the PCB. So these are little hot swap sockets. These are NeoPixel LEDs, but they shine through this way. They install from the back and they work from the front. That's what it looks like in the front. Pretty cool. I still need to do some soldering. I've got these resistors to put in. I forgot what values they were. But the really cool part is that these switches, they just stick in like this. So that means that if you have like a different preference for a switch today versus tomorrow, you can just switch your switch. And what's also nice is that you can use this PCB on any microcontroller because you don't need to multiplex the selection of switches. You simply do an analog read of the values. No diodes, no nothing. Don't need anything, which is pretty neat. So these just go in. Right now they fit kind of loose, but the point is that the housing that we're printing, they'll clip into the housing. And so it'll fit in a lot tighter. And in fact, if the 3D printer is done printing before, let's say, 45 minutes from now, which it should, then we'll be able to test it. I really wish I had a Voron 3D printer. Those things print fast as hell. I spent a lot of time, a lot of effort designing my own 3D printer, and really what I should have done was build a Voron. I guess that makes me a Voron, you know what I mean? Or at least something that rhymes with that. Oh, missing a piece. That's another thing we can do though. We could continue the design on my custom-made 3D printer. At some point that needs to be finished, now that I can afford tempered glass. So there we go. I was thinking about programming the buttons for a mute switch. Is pretty cool if a tap toggles mute, but a long press is momentary. You can definitely do that in software, like 100%. It's just I am a bit daft at software. There are some actual wizards that are among us
they could do it. Found my previous attempt. This is the previous attempt to this. So let's pull all these switches back out. Yeah, I mean, easy enough in principle. It would be difficult for someone like me, though. So yeah, this was the attempt I did before, before I was like super busy with college. And this is the reason why I didn't publish this video yet. So this, and you see how I'm not happy because it's not even the same size as the board. I got the critical dimensions wrong, but you will get to see how it works. If I just take one of these and pop it in here. It's actually, I guess it's better because I didn't align anything. Better to pop the switch into here so you see. Get the camera to focus. But yeah, this pops into here. That's now tight in there. And then this will fit down into its socket. Kind of like that. And you see if that one's lined up, the other ones aren't quite lined up. But now, the switch has no wiggle. And then to pop it back out, you just have to press it in. Actually, it looks like 1.5 mils. If you look, that clip is rather stressed. 1.5 mils might be too thick, but that's kind of easy to change. You can pop it out from the back like that. So the deal is that this board will be screwed into here, and then it should line up properly. You know, the new one at least, not this one maybe. And so yeah, that goes in like that. Comp sci before becoming a sound guy 35 years ago. Yeah, JB could easily do this. Mechanical engineer. Neat. I wish I had an engineering degree. It's not like it's too late for me to get an engineering degree. It's never too late. Thing is, you always have more time than you think. The deal is, I'm too busy. There's just no way I could commit to doing an engineering degree. I do want to get all the basics done slowly. That's a plan, but at the moment, I don't have the capability. Pascal and Fortran, neat. I do want to learn like machine code. Where's my other? Looking for my other macro pad, the one I used to play BeamNG live. You know what? A cheap ass degree is something I'd be totally up to getting. I don't think it's super important to have like a prestigious university degree, but I definitely would like to do the whole university degree process. That's kind of something I would love to do. Like if I had unlimited money, I would probably be taking university classes for sure. But that's not a reality. It's not my reality, at least. Where the hell? I can't find my macro pad. Well, anyways, I'm like drowning in freaking equipment here. Here's the rest of the PCBs for that video. So I got 10, 2, 3, 4, 5, 6, 7, 8, 9, and this one. Really cool, these the way it works with these hot swappable circuits. This is all hand soldered, so it worked out really well. Program in BASIC and use a compiler. I do sometimes program in pure machine code.
Oh man, so I want to program in machine code. Machine code is like so. It's like so like all the way down, right? It's like all the way into pretty much as deep as you can go, like low level. Marine Corps, huh? Interesting. I kind of want to cut another circle out of this. You know how we did here? Kind of want to cut one here. I say we do it. So grab this guy, bottom, sketch, plus sketch over here. Need to find the very center. Yeah, sure. There's the center. And then take a circle. This one I do want to be 69. There we go. Finish the sketch. Grab this circle. Cut it out. There we go. That'll be our secret, that this this circle has a diameter of 69. There we go. We're using a little bit less material. So basically, I'm being eco-friendly. Also, because I can't leave well enough alone, I'm going to add little... I'm going to round these corners. I don't know if it'll be stable enough, but that's why we iterate. There we go. It'll be nice here when it's 3D printers printing this one. That'll be okay, but here it might be a little bit iffy. Whatever. Nice. That's done. Porting a COBOL program to another flavor of COBOL using VI in a Unix machine. I had no idea what I was doing. Search and replace. Welcome to my life. I have no idea what I'm doing at all times. You guys want to see the parts that I designed for the 3D printer? I'll just switch you away in case there was some projects I was hiding in here. This one should save. Yep. And so I just have to warn you that I have no idea what I'm doing. I had no idea what I was doing at this time. So, MGH12, upring. I have to find my way back around here. Stepper holder. My God. I don't know what I was doing. XY idler. So here's one piece. This is one piece I have to redesign. So this is one of the chunks that holds. Let's see if I can orient you. Okay, so the y-axis is this way, the x-axis is this way, and the z-axis is this way. And so basically this bolts to extrusion here, this bolts to extrusion here, and this bolts to extrusion downwards. And then you've got a screw going into here. See the hex coming up this way, and then a bearing sits here, and then the timing belt goes around it. So you can imagine all the work I did today on just a simple case. Well, I had to do this, and I have way more parts than this too. So let's see. Let's see if I can figure out what all my parts were. This one, bed bracket. There we go. So there's another part. I didn't have object-oriented programming when I was in school. It's been harder to teach myself that. Man, if you got any tips for learning programming, I think I'll be able to finally commit to it very shortly. So here is, so this sits on one of the linear rails, and it holds an extrusion going across the 3D printer. Then you got two bolts going upwards like that, and they hold pulleys, and so the basically it goes, the belt comes around this way, around this pulley, and up to the carriage, then from the carriage around this way and this way. So that's another one. Apparently this one doesn't exist. I don't know why. Hot in bracket 1. Oh yeah, here we go. So this is the carriage. And so these are where the two linear things are, linear rails go, here and here. This here is for the belt to be secured. So it goes around like this and gets zip tied in front. And then these three here hold the stepper motor where the BMG extruder goes. So, I mean, there's a lot of, oh, and here's the holder for the BL Touch. So there's a lot of hours that go into this, and this is why I want to do these live streams so you guys can see how long it takes. Brace. Here's a corner brace. I'm probably going to be another 45 minutes. Hopefully the 3D print ends in another half hour. And then I'll be testing it on stream, and then time to eat. Let's see. Oh, here's another project I picked up at the same time, where I built the turntable. That's not done either. Yeah, I'm killing time until the 3D printer is done printing, basically. It's a belt lock. Oh, I drew something for Vero here. Board holder. Tool test, yeah. So yeah. Need to work on all these things. This is going to be so much work over the next coming months. Hopefully streaming twice a week. It's going to be interrupted a little bit next week, I think. The college has an event for me to go to, so I'll be there. But other than that, I mean, there is a lot of freaking work in doing all this. And then I'm going to release everything for everyone to, you know, take a look and tell me what I did wrong or whatever. Maybe I should have just used someone else's design, to be honest. Let's see. Core XY. You guys are talking retro computers. I have no idea what you guys are talking about. Maybe I should have just used this. Oh no, that's 2 belts. No, I want a single belt. Yeah, that's not what I want. I want a single belt. Nope. See all these brilliant people that upload brilliant designs? I want that to be me at some point. I want someone to look at my stuff and be like, man, that is really cool. And I know you guys say it sometimes, but you know, I want it to be finished. So people can be like, hey, I tried your project and XYZ. Thank you, Franco. I guess I was a little bit fishing for that. I think it's called like a HBot. The thumbs up emoji, some people don't like it simply because it's like it almost reads as good for you sometimes. You know what I mean? A fish. You have designs? Printables.com? How do I find you? So just search for Johnny Bergdahl. JONNIBR. Johnny, how do I find you? JB. Oh, gotcha. The fish. Requires that I have memory more than 10 seconds. Oh, the print is getting close to completion. That frickin' fan is so loud. And we're not running out of filament yet, but it's getting close. Gonna just search Johnny. Users. Oh, there you are, Johnny Bergdahl. All right, let's see what Johnny's been doing. 3D models. Okay, I think this is racist. That, you know, the Swedish guy made the IKEA parts. It feels like it's a little bit. Deltaco USB hub bracket. Is this your desk, Johnny? That's your monitor? Are you watching me like right here? I am going to copy link. Are you sure? Yeah. Go to site. Okay, that's where I found you. Okay. So yeah, this is your desk right here. Your monitor. That is a side desk. Oh, okay. So you've got the stapler, which it should be red swing line. I'm on the right. Okay. Good to know. Silica gel container. Oh, that's neat. These things that you put in you make dry boxes with. Ooh, cable organizer. I need this one. What's it look like? How does this print? Does it print in this orientation? Because it has overhangs. How do I print this? I want to print this. Feels like it should go here, this part down. Yeah, 'cause the 45. But then, how do these holes print? I have to print like 10 of these. Tape roll hanger, Prusa mini handle. No issues printing it like that. Okay. Desk drawer organization. So where do we get 5 stars? You have 0, 0, 4 stars. 5 stars, the Wemos D1 mini enclosure with cable pass-through. I should tell another maker about this because he uses Wemos D1s all the time. Holes are no issues printing without support. Excellent. Okay, I'll give it a shot. Yeah, that's actually a pretty neat little print. Look at you. Those skills. How long did it take you to model this? Like 5 minutes? Looks good. Oh, there's some weirdness happening here. I don't think they rendered this properly. Don't think it's in here. Cool. Oh yeah, I was looking for the Core XY types. I want the single belt type. Single belt. No, that's dual belt. Oh, that's an odd. Might be an error in the model, but I uploaded the Fusion files as well. Nice. Yeah, I don't think. I think they just rendered it wrong. Look at all these talented individuals. Yeah, this is what I'm doing here. So that's a single belt. Yeah. That's just about what I'm doing. So it's called HBot. HBot. Let's see. Yeah, that's more or less the design I was going for. Except I'm using linear rails, they're using bearings on things. Yeah, organizers, I need to get organized. You know what? I need to buy lumber to finish my, I have like a second workbench, but lumbers are so expensive right now that it's insane. Let's see if I can. Okay, so this is in Toronto, but kind of the same thing. So if you go to building, my God, building materials, lumber and composites. Okay, so 2x4s. $5 each. So expensive. Let's go like 2x3. Go dimensional lumber. Desk edge tool holders. Design screwed to the edge of the desk. Let me see. This one. All right. So. Okay, it screws down this way. Ooh, actually, I do need something like this. Next. Snippers. Okay. There's a lot of snippers. I think I want one, like a monolithic one with snippers and screwdrivers. Cordless screwdriver. Okay. This one is loop. Okay. It's an odd bottom. Tweezers, yeah, need that. Actually, I'm gonna hang my tweezers. Oh, you have the names of them too. How do you print this? Like this? Like this side down? Looks like it with the angles. Pen, yeah. Definitely need. Oh, does this go underneath? Like your desk, does your desk go into this groove? Because it seems like, right, you screw in from the bottom. Neat. Use supports, okay. So here, 2x3. Why can I not find 2x3 anymore? Maybe it's a stud. Uh, 2x3. Yeah, you save 50 cents. Well, that's interesting. It wouldn't work for my workbench though, because yeah, my workbench is like too thick. Where do you live, Franco? It seems like that's like a British thing. Like you don't have much space. I mean, I have not much space either, but in Canada, not much space is different than in Europe, not much space. What was I doing again? Oh, shit. Oh, whatever. Speaking of kettle, I can sure use another coffee. Let's see how much time left on the 3D print. It's getting there. 70% done. I swear, I think I fixed this printer by adding one frickin' command. I think the power off recovery was making it blob like crazy. Kitchen and living room are in the same room. Oh, are you like in a bachelor apartment? That would make sense. Yeah, this is what I'm doing here. HBot. Oh, interesting. I occupy so much space. It's actually problematic. So apparently the HBot has issues with the system racking. Uh, 126 square meters. Let's see. So your apartment is bigger than my house. My house is roughly 112 square meters, 1,200 square feet. So if you're 126, yeah, you're like 1,350 square feet. That's a lot. Yeah, so this is exactly what I'm doing here. So the belt goes across this way. It's mounted at 2 points there and there. That's awesome. Yeah, look at the size of this guy. Wow. If I go on Amazon, does it dox me? Hope not. Amazon. CA. Hello, select your address. What's the postal code for the... Why won't you let me tell me the postal code? K1M1M4. K1M1M4. There we go. You can shop Amazon now and have stuff delivered to the Prime Minister. That's an interesting place. Where in the world are you? Oh, what happened there? My background. Back to OBS. There we go. Let's see. Aluminum extrusion. Still really expensive. Actually, can I even get a Voron kit? No, cannot. I have this guy though. So if you see this one. So that is $439. And actually you can get it for $339. But I actually bought it used for under 200 bucks. which was nice. I just need to convert it to a little bit more workable. Would like to get a BL Touch on it, but apparently it's hard to install a BL Touch. Ew, you use Twitter? What's wrong with you? Copy link address. Oh yeah, yeah, my desk is just as bad. I think it's actually maybe even worse. Luckily, like I make YouTube videos, right? So I have like a clean spot, a little bit bigger than this, that I can fit a, you know, my frame in. But yeah, that's pretty bad. Yeah, so this guy, I need to add a BL Touch. Your sofa looks like that? Thankfully, my sofa doesn't look like that. I mean, it's not super clean though, but it is what it is. Are you guys, so here's my question. I need to upgrade my, my 3D printer, my Tronxy X3A. Hold on a sec, let me see. X3A. This guy here. And we're not going to be playing this. So, yeah, this guy I need to upgrade. Do you think that's more of a live stream type thing, or should I make a edited video of it? Now, if I do a live stream, I can't do an edited video because the footage will be like all awkward. But basically, I gotta replace these brackets here. These guys. I got to replace the lead screws and the nuts. I need to add a bed stiffener. All sorts of little things I have to do. I've already upgraded the extruder. The extruder on this one was pretty garbage, to be honest.
Choose that.
Copy link address. Just gonna pull this off screen because one day someone's gonna send me a not safe for work link. Oh, it is clean. Look at that. So where am I? Right here? I'm right here. There we go. And there's the little shelf with the stapler. Yeah, it looks really good. Is this like, do you have like a second employee here? Edited video might be a little bit easier, yeah, especially because the 3D printer is big. Zoom in. Can we, oh, I don't know if I'll dox you if we zoom into this. That's cool, got a TV up there. Look at the ceiling height. Either this is really low or your ceiling is very high. Pretty cool. I do like the sort of the hangout aspect. Had employees working there. Now that sounds like a nightmare. I don't know if I'd want to be sitting this close to someone else. I'd like my own office or at least cubicle. Let me check the 3D printer. What are we at in terms of time? We are 83% done. But it seems like it's going to be putting the finishing touches on a couple of the parts now. We're at 4.8 millimeter Z height, and I think we have 5 point something. So not too bad. Wish I could bring a camera there, but I cannot. I can nay. Ceiling height is 2.6 meters. Let me just 2.6 meters, 2 feet, 8.5 feet. Wow, that is really high. That is pretty neat. I like it. Let's see. Do I have?
Ladies and
Whoa! No, be quiet. Yeah, it's you know what, the X3A is not a very good. Oh, look, I wonder how come this one has 3 million views. This one here. Another link. Copy link address. Oh, that looks really neat. That's really cool. Let's see. Yeah, anyways, eventually, actually, I could show you if you guys build in 1840, all ceilings are 10.7 feet. Huh. I can show you all the upgrade stuff we need to do to the 3D printer. And like eventually it'll all get done. Gonna keep my pink filament at the ready, but it seems like it's not. I mean, there's still filament on the roll. That's too heavy to put over there. And pink. There we go. I even have ABS pink. Okay, so I have these lead screws to replace. Hope my address isn't on this box. It isn't. Okay, so I got these 2 lead screws to replace. The ones on the printer right now are crooked. And new nuts to go on that too. These guys here. And then I have these guys. The all-metal Micro Swiss hot end. Apparently this will bolt right up. And I have to remove this heat cartridge here and thermistor. And I'll just reuse mine for the moment until I do a 24 volt conversion, basically. And then add some insulation to the bed on the bottom so it heats up and stays hot faster. I got a boot for the Micro Swiss. So that'll go on that. And then when we do the 24 volt conversion, there will be, let's see, I think it's this box here. Oh, that's dusty. So once we do the 24 volt conversion, then I'll have these guys. This is a new main board, Big Tree Tech SKR. Oh, it has a SD card in there. SKR 1.3. So that'll go in, which will be pretty exciting. And I'll have these. Which ones are these? TMC 2130 drivers. So that's these guys here. So they'll go in there. I've never programmed a new main board, so that's going to be interesting to say the least.
There should be a default configuration, but we'll see. My basically my 3D printer will become the ship of Theseus. We won't know, you know. Oh, there, 2130. It says right there. And then this also. The screen. So new screen, new brains. I have a 24-volt power supply. Hopefully it'll be strong enough. And so, yeah, it's going to be done in 2 phases. Oh, and I have some 3D printed parts to install as well. So the bracket I was talking about has to be replaced. Might as well put all the pieces together. So these 2 brackets, so they will hold the nuts on. So they'll actually go, so the stock ones go like this, and they're screwed into the top here. And so all that's holding it is the nut on the backside. But these ones, they'll be installed like this. So the carriage will be pushing down on the much bigger flange that is here. So that'll be good. You can see it's adjustable too. So I got 2 of these, plus this here is a tensioning mechanism for the wheels. So it'll be able to be tensioned for the slop to be taken out. Also, this piece here, this is the Y-axis motor. So this will sit kind of like this. Stepper motor in here, gear comes out on this side, and then this is the spot for the limit switch here. So this is one piece. It's a lot more solid than what's on there. So those things are all going to have to go on. Buy some new extrusions. You can just sell the old printer. I mean, I guess. But it's the ship of Theseus. Plus I don't think I can get very much money for my printer. It works, but only sort of. Oh yeah, and then eventually I want to add a BL Touch as well. When I do this conversion, I'll do BL Touch as well. I mean, I might just buy extrusions someday and then just run the stock electronics, but the point is to get away from the stock electronics, so who knows. I might I was also thinking of just replacing the electronics on this one with a ramps kit, which I can show you as well. Let me just throw all these things in here. Actually, it could go in this box too. Throw everything into that box. So I want to replace it with a ramps 1.4 kit and then build another 3D printer, but like how many 3D printers am I going to build? Like this. This can go in there too. There we go. I've got a storage container that's empty now. Like so. Done. What was I going to show you? Oh yeah, the ramps. 3D printer. This is my 3D printer parts box. And here is a ramps 1.4 board. So I have to fix the this got broken in shipping, and I also scratched off one of the wires here. 2 of the wires. Yeah, so I damaged it a little bit. But other than that, this guy here with these shitty drivers, this could actually run a 3D printer at the moment as well. I'm going to probably use these external MOSFETs for the bed. I've got an extruder. This is like a cheap extruder. I don't use these anymore. I use double double gear extruders, so this one's probably going to go in the garbage. But I've got stepper motors. I've got enough of them in here. Got the T-nuts. I've got a E3D V6. So like I've got enough parts. I could build. Oh, and I have the LCD in here too. So I could actually just replace the main board in this one with a ramps board and just stick with 12 volts. I mean, that's a very big possibility as well. I might do that. And then, but then what do I do with my SKR? Oh, I could use my SKR actually on the X5. Oh man. So I have that bigger one. Like use the XKR for. I think that's what I'm going to do. I'm going to convert this 3D printer to a 12 volt ramps board. That's a good idea. Because I think the ramps will work just fine. There we go. See, I got to work that out. So I got the ramps board for that one, and then the 24 volt X5. And then if my X3A with the ramps board works really well, then I can sell it when my big custom one gets finished. There we go. We worked it all out. Perfect. How long on the print? Kind of getting antsy. Should have started this a little earlier. 94%. We're almost there, folks. Just needs to go. I thought I built a lip onto it, didn't I? Did I mess that up? I don't know. We'll see. It's still doing its thing. Someone called Doug. Oh, just follow it on Twitter. Yep. I mean, I'm kidding. I'm using Twitter too. I just think it's cancerous. Let's see. Got a notification. Oh, there we go. Yeah, Johnny, you showed off your thing. Oh, your mug. Wow. Okay, so that's the new, I think that's the new plan. I will replace the crap electronics in the Tronxy with the ramps board. Stick to 12 volts. And then upgrade the X5 SA with the SKR 1.3 board, this board. And then the X5 SA will be like a beast mode printer. And this one here I can try to convert into like a more precise small parts printer. That's good. That's the plan. So now let's see, can we find a ramps screen? We do a ramps 1.4, right? Images. Yeah, that's what I have. 1.4. Okay, so BL Touch on ramps 1.4. Can you do it? Yes, you can. Well, I'll be. Okay, and then download.
Configure. Install. Can you use Marlin 2? You can with 8-bit AVR. So you can use Marlin 2 with Arduino? Yeah, I'm already following Emily. She is interesting to follow. I actually like her old Toyota too. She painted her Toyota like that greenish yellowish color. It seems to say I can use Marlin 2 on ramps. So I think I'm good. I have to read up on how to set it up though, set up Marlin, but yeah. Wait, is it already set up for ramps right off the bat? That would be awesome. Also, how much would a new ramps board cost me if I can't fix mine? I mean, I should be able to fix it. $3. Oh no, wait, that's a driver. Rams 1.4, $6. But I have a ramp, so... Oh, print is done. Switch to webcam. Okay. Moment of truth, everyone. Here it is on the print bed still. I'm going to try not to flex the print very much because it is still hot. So this is all the gooping it was doing. There it is. It's got the little lip on it and everything. Let's see if it fits. So obviously there's a lot of play, but we kind of designed it that way, if you remember correctly. The important thing will be if all the switches fit in there. And we didn't run out of filament, so we did not need the pink filament. But I'll keep that in mind, and the production version will be pink. Okay, so let's bring this bed back. I'll be able to finally shut down the 3D printer with the loud frickin' fan. I'm just letting it cool down at the moment. Okay, so let's see if I can bolt this together first and foremost. I need some M3 screws. Now my screws might be too long because we need the rear portion to hold it together, but that's okay. Ouch. I'm gonna cut myself on plastic. Okay. I need a screwdriver. A bigger one. Where the hell's my big screwdriver? Nope. I got all these, but I need one size bigger. This thing is blocking the light too. Oh, Dang, damn it. Always manage to lose my tools. This is why making videos takes so freaking long. Maybe it's in the mess over this way. I have the right size in here. I have Torx. Torx work. Close enough. All right. Oh no. Get in there. Too big. I know it'll bottom out, but that's okay. Well, it fits tightly. It's good. I think I did manage to warp the 3D print by letting it cool too fast. That's okay. No, not too worried about it. I do need an organizer, but it wouldn't fit my desk. It's not the way, like my desk, the edge is like that thick. Okay, so that fits. Let's pick a relatively clean hole here and see if we can just drop the switch in. It's a bit tight. Tolerances might be a bit tight. That's in. So if you look down in these holes, there's 1 and 2 pins. This one here has no pins inside. So the switch did fit. Look at that, super solid now. Done. Was planning to see if that can work for marketing them. Mark my screwdrivers with type and size. Oh, print on shrink tube. Interesting. So this works. We are good. I just need to print out the bottom section, and then it seems like later this week, maybe this weekend, I can film this video. So yeah, that was pretty cool. Thanks everyone for hanging out. Yeah, this will work, and then hopefully the bottom part is strong enough. It'll hold it about 30 degrees, kind of like that. And you should be able to make it work. All right, so I guess that is it. It is time for food. If Miss Verowack is still listening, it's time for food. I'm starving, and we're probably gonna have some leftovers. No, we're making chicken today. True. Maybe you should have made that. Anyways, thanks for watching, everyone. Have a good one. Thanks for hanging out. And yeah, if you have electronics enthusiast friends, tell them about this channel, because there's like 24 subscribers. Have a good one, everyone.